Here is a quick review on similar right triangles, focusing on finding leg lengths. Let's start with the right triangle, and we're going to drop an altitude from the right angle. I'm going to turn my triangle around so I can do that a little bit easier. So I'm going to drop that altitude, which is perpendicular to the hypotenuse. We get three similar right triangles, a small one, a medium-sized one, and a large one, and that's the original one, and I'm going to turn it upside down so we can see it. Now these are all similar triangles, so as long as we can match up corresponding sides, we can find missing lengths. So since they're similar, they have corresponding hypotenuses, they have corresponding longer legs, and they have corresponding shorter legs. And you can use these values to set up proportions. But if you look at where the different hypotenuses are in the shorter legs and the longer legs in the original figure, it can get really confusing. So we're going to use another method in this video to find missing leg lengths in the original triangle. We're going to use the geometric mean, and the geometric mean of two numbers is just the square root of their product. So to find the geometric mean of A and B, you multiply them and take their square root. It gives us x, the geometric mean. So if I want to find the geometric mean of 2 and 8, I'm going to multiply them and take their square root. So that would give us the square root of 16, which is 4. So the geometric mean of 2 and 8 is 4. Let's take a look at how knowing what a geometric mean is can help us with our similar right triangles. I've taken our triangles and I've labeled all the different segments that are formed when you drop that altitude. In another video, we've already figured out how to find the altitude. It's the geometric mean of B and C. But to find E, that is the geometric mean of B and B plus C, the original hypotenuse length of that bigger outer triangle. To find F, you also are going to take the geometric mean of the segment of the hypotenuse, in this case C, plus the entire length of the original hypotenuse, B plus C. Let's look at a few examples to see how this works. In my first example, my X is where the F is in my upper drawing. So I'm going to take the geometric mean of 2 and the entire original length, 6 plus 2. Well, 6 plus 2 is 8, so 2 times 8, and that would give us the square root of 16, which is 4. So that missing leg length is 4. Let's look at another example. This time I am looking for that E value in the original drawing. So it's going to be the hypotenuse segment closest and the entire length, but I don't know that segment. They haven't given it to us, that length. But we can figure it out. The whole length is 9. The other piece is 4, so using the segment addition postulate, we can figure out that the hypotenuse length we need is 5. So I'm going to take the geometric mean of 5 times the entire length, 9. And rather than make this square root of 45, 9 already is a perfect square, so I'll just take its square root and get 3 radical 5 directly, my simplest radical form. My last example, I am missing one of the hypotenuse lengths. So that X is down there. I know the leg length. So it looks like F is the square root of C, B plus C. So I'm going to set it up that way. 10 is the geometric mean of X and 20. To get that X out of the radical, I'm going to square both sides. And it's easy to square radicals. You just get what was ever inside the radical once you square it. So 100 is 20x. And this gives me 5 equals x, but I do want to turn that around so it looks like x equals 5. So I can find that missing segment length right there. I hope this helps. You work problems like this. So basically, to find the leg lengths E and F on that outer big triangle that we started with, E is the geometric mean of B and B plus C, which is the entire hypotenuse length of the original triangle, and F is the geometric mean of C and B plus C, again, that entire hypotenuse length. So I just remember, whatever leg you want, it's the geometric mean of the hypotenuse segment that is touching the leg you want, and the entire length of that hypotenuse. So thanks for watching, and I hope this helps you.